Hello, good day. Now here we're going to look at some of these questions involving logarithm. So evaluate the following. Let's look at the first question here. Log root 8 to base 2 plus log root 3 to base 27. It would have been better if the base are the same so that we just use multiplication here. Okay, but since the base are different, we first of all evaluate each of these base independently. Okay, so we say let log root 8 to base 2 is equal to u, and log root 3 to base 27 is equal to v. And if you recall from definition, if we have log x to base a is equal to n, from definition it means that s is equal to a raised to the power of n. It means that the logarithm of any number is the power to which the base must be raised to give that number. So here we can use that principle to say that root 8 is equal to 2 raised to power u from here. Okay, so we say 2 raised to power u is equal to 8 raised to the power of half, because root here is simply means half. Okay, here we need to express 8 so that we have a common base with uh, 2 on the left hand side. Okay, so 8 is the same thing as 2 raised to power 3, uh, and this eventually becomes 2 raised to power u is equals to 2 raised to power 3 times the previous power, which is half, and eventually 2 raised to power u is equals to 2 raised to power 3 over 2. Then to obtain the value of u, we equate powers. So we just look at the power. U is equals to 3 over 2. Okay, u is 3 over 2. Similarly, we said that let log root 3 is equals to 27. Log root 3 to base 27 is equals to v. It means that root 3 is equal to 27 raised to the power of v. So root 3 is simply 3 raised to the power half, and we need to express 27 so that we have a common base. So 27 is the same thing as 3 raised to the power 2, and if we replace 27 with 3 raised to the power 2, eventually 27 raised to the power v becomes 3 raised to the power 3 v. Okay, because the power we have to multiply the power here, that's 3 times v. So here we equate powers again. To obtain v, we equate powers so that half is equals to 3v. Now to obtain the value of v alone, is either we multiply both sides by 1 over 3, or we divide both sides by 3. Okay, divide both sides by 3. All right. So v eventually becomes 1 over 6. Okay, here uh, we've known that u plus v, or v plus u, is equal to 1 over 6 plus 3 over 2, because u is 3 over 2 and v is 1 over 6. By addition, the LCM of 6 and 2 is 6. So 6 divided by 6 is 1. 1 times 1 is 1. 6 divided by 2 is 3. 3 times 3 is 3. So 1 plus 3 times 3 is 9. And 1 plus 9 is 10 over 6. So the common factor is 2. 2 in 10 is 5. 2 in 6 is 3. And this becomes 5 over 3, which is one whole number 2 over 3. Now let's look at number 2. We say log 0.125 to base half. Say here we say let log 0.125 to base half is equals to u, so that 0.125 is equals to 1 raised to the power of u. Okay, that's the from definition. So here we have to look at this 0.125. We have to express it in form of fraction and look for a number, so that if we accommodate this base here, which is 1 over 2. So 0.125 is the same thing as 125 over 1000 as fractions. So 125 times 1, and the denominator 1000 is the same thing as 125 times 8. So the whole of 0.125 is the same seen as 1 over 8. Okay, so this becomes 1 over 8 is equal to half raised to the power of u, but 1 over 8 can also be expressed as half raised to the power of what? 3. So that half raised to the power of 3 is equal to half raised to the power of u. And here you see that the base is half here. So all we need to do is just to take the power, so that equating powers, u equals 3. So therefore log 0.125 to base half is equals 3. Now number 3 question, it says log open bracket root 8 times the cube root of 2 times the fourth root of 32 close bracket 2 base 2. Here we need to tackle what we have in the bracket, which is the logarithm here, which is root 8, cube root of 2, and the fourth root of 32. So the square root of 8 is the same thing as 2 raised to the power of 3 over 2. Root 8 can be expressed as this. Similarly, cube root of 2 is the same thing as 2 raised to power 1 over 3. And the fourth root of 32 is can be expressed as 32 can be expressed as 2 raised to power 5, which is 2 multiplying itself 5 times to give 2 raised to power 5. Then multiplied by the power times half is equal to 2 raised to power 5 over 4. Okay, if you look at what we have here in the term in this bracket, you see that the base are the same, and the sign here, the operation sign, is multiplication. That means this is typical indices. So we use indices to operate what we have here. This becomes 2 raised to power 3 over 2 plus 1 over 3 plus 5 over 4. And the LCM of the denominator of the fraction, 2, 3, and 4 is 12. 12 divide 2. 12 divide 2 is 6. So 3 times 6, that gives 18. Then 12 divided by 3, that is 4. 1 times 4 plus 12 divided by 4 is 3. 3 times 5, and that gives 15. So if you sum all these things together, I give you 37 over 12. Okay, so the whole of this term here on the left hand side is equal to 2 raised to power 37 over 12. And if that is substituted in the logarithm, it becomes log 2 raised to power 32 over 12 to base 2. And from the law of logarithm here, this is the power, which is 37 over 12. We come behind acting as a product, 32 over 12 log 2. Remember that log 2 is 1. So that this logarithm here, the logarithm here, the whole of this logarithm is equal to 37 over 12. Then number 4, they say 5 raised to the power of minus 3 log 2 to base 5 times 2 raised to power 2 log 3 to base 2. Here we need to do some transformation. If you look at the base that is raising this one to minus 3 is 5, and the base of the logarithm is also 5. All we need to do here, we look for a way around to move the logarithm, which is 2 here, back to replace 5, and 5 will eventually be substituted for the position of 2. So similarly, the power here, the base here is 2, and the power here is 2. Here the logarithm is 3 and the base is 2. So here we transfer this logarithm 3 here to replace the base here, which is 2, while the 2 will be transferred to this logarithm. Then but the power here minus 3 and the power here, they are unaltered, so they are not tampered with. So 5 raised to power minus 3 log 2 to base 5 can be written as 2 raised to power minus 3, because the 2 is now replacing 5 and 5 is now replacing 2. So to become log 5 to base 5, and here log 2 log 2 raised to power 2 log 3 to base 2 can be written as 3 square log 2. But you know that log AA is 1. So log 2 will be 1 and log 5 will also be 1. So that this expression here will become 2 raised to power minus 3 times 1 is equals to 1. From negative logarithm, negative indices, this becomes 1 over 3 is equals to 1 over 8. Similarly, for 3 raised to power 2, log 2 is equals to 3 square times 1, which is 3 times 3, and is equals to what? 9. So therefore, log 5 raised to power minus 3 log 2 to base 5 times log 2 square log 2 square log 3 to base 2 is equals to 1 over 8 times 9, which is one whole number 1 over 8. Please, if you like this video, help me subscribe and also help me share on your social media platform. Stay cool until I see you in my next virtual class.